Okay, so yo, your girl story coming at you.
Why?
It's my hook.
Why?
That's good. All right.
Okay. We have, wait, I'm just encouraging you to subscribe and, like, you know, buy my merch. I have 2 students here with me.
Add a dislike to this video.
I have 2 students here with me, and we're going to compare index of refraction qualitatively. So in other words, without numbers. Okay, so here's what's going to happen, and here's how you can think about it. I'm going to tell you the scientific way, and I'm going to tell you the way that I actually memorize it. Okay, so we have let's have something that's more dense here. Okay, so this is going to have a higher index of refraction, and then out here we'll have like air, so a really low index of refraction. And of course we want to focus on the normal line. We're going to measure everything from the normal line. Be very careful. Sometimes they like to have you measure from the surface of whatever it is, and that's just because they're sadistic. Okay, so in comes some light, and it is going like this. So we've got an angle here that looks like about 40 degrees. You can just eyeball it. If you're going from something less dense into something more dense, when it comes into this, what do you expect to happen with the angle? Will it get bigger or will it get smaller? It actually gets smaller, okay? So here is the way that I have memorized it, okay? Out here, I like to think of this, okay, index of refraction is really small out here, okay? So the air is like light and free, and I like to think, oh, this angle can stretch out, okay? When it goes into the higher index of refraction, I like to think, oh no, the angle got squished. This is not a scientifically accurate way of describing it, but it works really well, okay? So you can kind of think, all right, bigger angle, oh my gosh, that's my angle, it's terrible. Bigger angle, greater, or whoa, simmer down there, story, okay? You could think lower index of refraction. Okay, let's practice. Okay, so on the top we have this little setup going here. So we have some material out here. Okay, so we'll call this material A, and material B, material C. And they'll ask you to rate the density or the index of refraction of these guys. All right, so let's go through and look. So first thing you want to do is you would want to compare the angles. Okay, so we're going to go and first we're going to make sure we're comparing them from the normal line. So we're looking at, let me see, color code this guy versus this guy. Where is the bigger angle, in A or in B? B, okay? So where, okay, think of it as like, okay, I'm going into less dense material, so I'm stretching out. So which one has a lower index of refraction, A or B? B, yep, so NB, you stretched out, is less than NA. Okay, that's one little thing. All right, let's go to the next guy. So the tricky thing is just to kind of keep track of that normal line and not accidentally go and measure from the surface, because your brain will want to do that. So you always go from the normal line, that angle compared to that angle. Wow, I really didn't make that very obvious, but what do you think? We can zoom in.
I'm going to say B is bigger.
I think B is definitely bigger. Okay. Okay, this is the new feature I just found. Very excited about it. Okay, so angle, what did we say? Angle B is bigger?
Yes.
So which one is lower?
B, yeah.
Okay, so NB is less than NC. I should have made this problem a little more obvious. It's kind of hard to compare these guys. Well, let's just go with that. Okay, yeah. That's good enough. Good enough. They'd make it more obvious if we wanted to compare the other two. Maybe there's a one. Good enough. All right, so let's look at the next one. I got rid of a layer because I don't want to do that. Okay, I'm tired. Okay, so let's go through and go poop, 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 poop. Okay, so let's compare A, B, and C again. So A compared to B, which one has the greater index of refraction?
B.
Good. NB is greater than NA. You good?
Yeah, no.
Okay. Okay, good. All right, so then we're hitting here. So boop and boop. Okay.
So
Yeah.
B has a
Yeah.
greater.
And then C is less.
Let's see. So then you can kind of go through. Okay. Which one had, like, I almost think of it as like the bigger reaction, which had the biggest change going from B to C? Well, you can see that if A and B are definitely different, right? But they're not, you can even just look at the angles. They're not experiencing quite as big, quite as drastic as a change. So A and B are probably closer, in fact, they are closer than B and C. See how there's a huge change in that angle? So how would I write this? Okay, so obviously the biggest guy is going to be NB. So NB is greater than NA, which is greater than NC. Okay? Now, they like to sometimes ask about the velocity. All right? In that situation, remember that it kind of flips now. Okay? If you have a high index of refraction, you're going to go slower. Okay? So the easy way to do it is I always do the comparison between the index of refractions, and then I just write it. I just go like this. Boop, boop. Boop, 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 and then I just switch the directions of the comparisons. So, boop, boop, done. Good?
Good enough.
Good. All right, say bye, YouTube.
Bye, you too.
Peace.